Hello and welcome to Algebra 2, Chapter 3.6, and today we're going to be solving systems of linear equations in three variables. So what you need to remember from the other day when we graphed one linear equation in three variables is that it graphed a plane. So we are talking about three planes here, and there's a few ways three planes can interact. This first picture here shows that all three planes are intersecting at one point. Okay, and they wouldn't necessarily have to be perpendicular to each other. They could be at angles, but you could get three planes to intersect at one point. If they were perpendicular to each other, think about it as being the corner of a room. Okay. You could also get three planes to intersect at exactly a line. So think of like the binding of a book or something like that. Okay, all three planes would intersect at a line. The other three options here are that all three planes either don't intersect or they don't intersect at the same place. So this one here is that they're just parallel planes. Okay, then that's going to be no solution. These two, they intersect but only ever two at a time. So two of them intersect here, two of them intersect here, two of them intersect here, right? Or two of them here, two of them here. And so those wouldn't have a solution either because they don't all three intersect. So what we're looking at is here's no solution, here's one solution. This is going to be equivalent to infinitely many, but we're going to do something a little bit different because specifically it is that certain line in there. So how do we solve these? We're going to use linear combination or elimination, and essentially you're going to do elimination 3 times. Okay, so to start out with, you're going to choose any two of the original equations and you're going to eliminate one variable. Then you're going to choose two different original equations. So there's going to be 3 original equations. So let's say you chose 1 and 2 to begin with, then maybe you choose 1 and 3 or something like that. 2 different original equations, and you have to eliminate the same variable that you just eliminated in step 1. What that leaves you with is 2 new equations that have the same 2 variables. You can solve that using elimination. So you're going to solve that new system using elimination and then taking the 2 known values back into one of the originals to get the third one. So eliminate one variable, eliminate the same variable, solve the system you've created, solve for that first variable you eliminated. So we're gonna do 3 examples, so let's look at these. So here's the first one, and I'm going to start out by labeling the equations so that you can kind of follow them throughout. So here's equations 1, 2, and 3. And we want to eliminate some variable, and it doesn't matter whether it's x, y, or z, and it doesn't matter which equations you use. To make it easy, I'm just going to pick equation 1 and 2, and I'm not going to multiply them by anything because they are all ready to eliminate z. So I'm just going to rewrite equations 1 and 2. And by the way, I think your paper might have a typo. It is -11. And we're going to add these together. And I'm going to call this equation 4. And it is going to be 3x plus 4y equals -10. That's equation 4. Okay, so there's step 1. Step 2, pick 2 different originals and also eliminate, in this case, z. Well, I'm going to pick 1 and 3, and I'm actually going to do 1, I'm just going to write it in here, 1 times 3. So that looks like 3x plus 9y minus 3z equals -33, and then 5x minus 2y plus 3z equals 21. And we're going to add these together, and this is going to be equation 5. It's going to be 8x plus 7y equals -12. So our next step is that we've created a new system. We have equations 4 and 5. So here's my system of 2 equations and 2 unknowns, and you're going to solve this just like you would typically solve a system of 2 equations. I'm going, let's see here, 3 and 8 would really need to become 24, and 4 and 7 would need to become 28. So tell you what, let's multiply the top one by 8 and the bottom one by -3 to make the x's be opposites. So we're looking at 24x plus 32y equals -80. And -24x minus 21y equals +36. I'm going to add these together. The x's cancel. We're going to get 11y equals 44. Let's see here. -44, there we go. Divide by 11, y equals -4. So there's y. The next thing you have to find is x, because you have to go back to these two, because all you know is one of them. So you can't go back to the original because that would still be 2 unknowns. So let's use equation 4. So I'm just going to tell you here that I'm using 4. So this is 3x plus 4 times -4. And you're going to solve for x. Add 16, so we get 6 on the other side. So it looks like x is 2. And then the last step is to go back to one of the originals, doesn't matter which one, and now we're going to find z. So let's go back to 2. And so we're going to have 2 times x plus y plus z equals 1. That would be 4 minus 4. So it looks like z equals 1. Okay, your answer here is going to be an ordered triple. So my answer, this would be x, y, and z. Okay, and you can check it. It should check in all 3 of these. So you should take the time and go 2 minus 12 would be -10, minus 1 more would be -11. 4 minus 4 is 0, plus 1 is 1. 10 plus 8 is 18. Plus 3 is 21. Check it. It should work in all 3 of those. Okay, now that we've done one, the next ones hopefully will go a little bit quicker. Okay, so first of all, I might suggest that just kind of label your equations so you can follow them throughout the problem. And I want to eliminate one variable, so let's go ahead and eliminate x's. I'm going to use equations 2 and 3 and go ahead and add those together. So I always rewrite them so that they're next to each other. Okay, so we're going to add these together and get equation 4, which is going to be -9y plus 9z equals -3. So there's equation 4. And I'm going to take equation 1 and 3 to get my other equation, but I'm going to take equation 3 times 2. So equation 1 is going to be 2x plus 3y plus 7z. Let's try that one again. Equals -3. And twice equation 3 is going to be -2x minus 6y plus 16z equals 2. Make sure you multiply all the way across. Add these together for equation 5. And that's going to be -3y plus 23z equals -1. So then you're going to bring equations 4 and 5 together. I have to apologize, I lost my good stylus, and so you're having to put up with my old one here. So I need to eliminate something. Let's go ahead and eliminate the y's. So we multiply the second one by -3. So it's going to be a positive 9y minus 69z equals 3. Okay, add these together. That's going to be negative 60z equals 0. Divide each side by negative 60. Z equals 0. So the next one you have to find has to be y, because if you go back up to equations 4 and 5, that's your next unknown. So let's just use equation 5. Negative 3 plus 23 times 0. So negative 3y equals negative 1, y equals 1/3. And now you go back to one of the original 1, 2, or 3 to find x. So let's just do equation 2. So it's going to be x minus 6 times 1/3 plus 0 equals negative 4. So x minus 2 equals negative 4. X equals negative 2. Okay, and remembering that your answer is an ordered triple, that would be x, y, z. And check it in all three of them. It should work in all three. All right, let's try one more. We're going to get faster here. 1, 2, 3. And what do we want to eliminate? Let's eliminate x's. So I'm going to take 1 and 2, except I'm going to multiply number 1 by 2. So that's going to look like negative 2x plus 4y plus 2z equals 6. Make sure you multiply all the way across. And 2x plus 2y plus z equals 5. Add those together to get equation 4, which is 6y plus 3z equals 11. And then I'm going to do 1 and 4. Notice I'm picking, 1 and 3, not 4. Notice I'm picking the ones that have all opposite signs already. And so I need to take number 1 times 4 this time, which is going to look like negative 4x plus 8y plus 4z equals 12. And 4x plus 4y plus 2z equals 6. Add those together for equation 5, which is 12y plus 6z equals 18. So bring those together. We got 4 and 5. And if you want to, you could do what I was doing to begin with and say already like, okay, we're going to take this one times negative 2. And then we get negative 12y minus 6z equals negative 22. 12y plus 6z equals 18. Add these together. Y's cancel, z's cancel. You get 0 equals negative 4. Does 0 equal negative 4? No solution. So as soon as you get a contradiction someplace, your contradiction is your false statement, your answer is no solution. All right, we'll finish up the rest of the examples in class. Let me know if you have any questions, and have a great day.